Hello all, welcome to another LeetCode problems. Today we are going to solve problem number 1721, swapping the nodes in the linked list. So if I read the problem description, so you're given a linked list with the head, and then you have to return the linked list. That is the same linked list you have to return after swapping the values of kth node from the beginning and then kth node from the end. So k is something that you have given, and then when you have, if you are reading a linked list that is starting from first node and going to the end, so you have to swap. So remember, you don't have to swap the nodes, you just have to swap the values of the node. So kth element from the start, so that is, in case here k is 2, so k, the second element we have to find out, so that is this one, and then kth element from the last, so that is this one, right? Uh, the second last element basically. Let's say k is 3, so in this case k will be same, right? But in the k is given as 2, so we have to replace this value and then this value, that is 4 and 2, and then return the same linked list back to the result. So that's the problem here. So if I look at the problem, it's quite if it's quite simple and then easy to solve it. So you are given a k as a starting point. So if you know how to traverse a linked list, so finding a second position would be easy, but finding the second last position will be difficult. That's the challenge only here. If you are able to determine what is the second last element, or based on the kth element, that then the entire problem is solved. Then you just have to swap the values here and there, and that's it. That's what you need to do it. So one way, simplest way is, what you can do is, if you find trouble traversing a linked list, you can convert this whole linked list as a list, as a normal Python list or Java list, whatever language you like it, and then you can swap the position. So you now, in traveling in the list of will be easy. Either it is a list or array, whatever you say, and then you can just replace this value with this value, and then finally convert that array back to the linked list and then return. So there is one way, but there is a better way I'm going to talk about. Instead of doing that one, you can, without even converting into the array or list, you can simply use two pointer approach on the linked list, and then that two pointer approach can help you to find what is the kth element and what is the k minus 1 element, sorry, second last element, and then you just need to replace the values. So what we are going to do is, let's say you are given a linked list 1 2 3 4 5. So we're going to two pointer approach. So we are going to have to one pointer as a fast pointer and one pointer as a slow pointer. So, and both will point initially to starting position. Now we have to traverse till k equals 2, right? So that is, I can simply have for loop that will say k minus 1 travel to k times, and then and I keep shifting my fast pointer. So initially k is 1 and the starting point here, and then I shift again k equals to 2. So basically I will have for loop that will increment my fast pointer. So I can just simply has a for in the range of k minus 1. Remember, I don't need to do k because then it will shift to the third position. I just need to do a k minus 1, that is only one, because I'm already on the first position. So this simple form. So that for loop basically what will do is, so initially fast is pointing to head, that is first position, and then I have to traverse till k minus 1, so fast will now point to here. You might think how it is going to work. So it is, I'll show you when I'm writing the code. So think of as fast is your starting position, and then instead of, when you increment your fast pointer and go to the next one, we just had to traverse only once, so that it will automatically at the k position, k equals to 2 position. So now fast will point to here, right? So this is going to be basically your first element that you want to swap. So you can say, you can, persist that as part of another value or another node, okay, another object in Python. Now your fast is pointing to here, and the slow is still here, because remember we didn't increment the slow, right? Now what is happening is we need to find out how somehow if slow will reach here, that is my that's where I need to stop. So what we can do is I'll take the help of fast itself, because now fast is pointing here. I'll take the help of fast and go till the end, and same time I'll increment my slow as well. So this fast will basically help me to identify where is my last position. Remember, there is a one fast, and there between fast and slow there is a gap of one element, right? So as soon as fast will reach here, slow will reach automatically here, right? And that's what I need. In case k is 3 or k is 4 or k is 5, right? Let's say k, this another uh, element. Try to visualize this. So let's say k is 3 now. So what will happen is maybe I'll take another screenshot. Let's say 1 2 3 4 5 6 7. Now let's say k is 3, correct? So what we'll have to do is you have to replace this one, that is third position, and then this one, right? So initially I ran the for loop and my fast came here. Let me change the color here. Now my fast is here, and slow because initially it was still pointing to here. As soon as I move my fast pointer, I'll also increment my slow pointer. So my fast went here, slow will went here. Fast again will jump here, slow jump here. Fast again jump here, slow will again jump here, and then fast reach to the end, slow will reach to the here, and that's it. As soon as my fast reaches to the end, I cannot go further. Slow will here. So automatically, what will happen is your slow will automatically point to the k, the third last position, that because k is equals to 3, right? And that is your this particular one. Now fast was initially here, and then slow is basically here. Now I can swap these values back to that. So that's the logic here. We'll look into the code, and that I think that will be easy to understand. So let's go back to the code section. So as I mentioned, I'm gonna have two variables. So that's gonna be a fast and slow. Both will point to head, right? Now I need to increment my k. So I say k minus 1, because I just need to go only once. Otherwise, if we do k2, then it will move to the third position, and then I keep incrementing my fast position. So fast equals to fast dot next, and that's it. So now you find your first element that you need to swap. So fast will point to first one. Now you need to look at the second one. You need to find the second one. For that, I'll increment fast and slow both. So what you can do is you can use a while loop instead. While fast dot next is there, you increment fast and fast and slow both. So I'll increment fast dot next, and then also increment slow. So it goes to slow dot next. Now slow will point to my second element at the end. I explain here. So as soon as you increment fast and slow both, as soon as fast will reach to then slow will basically at this position. That is second element. Now once I have these values, I'll just replace the values. So in Python you can just do like this: first dot val, second dot val equals to second dot val, and then first dot val, and then I'll just return the head because it's passed by reference, so everything will be updated in your actual uh, linked list. So let's try to run this. Hopefully I didn't make any mistake. So yes, so all the tests is passed. Let's try to submit it, see how it goes. Hopefully that should work. Yeah, that's pretty much efficient here. So that's our logic. Hope you like the video. Without using extra space, we solve this problem. We just use our 2 pointers to traverse the linked list, and then we return the head value, that is final linked list. Thanks for watching. See you in the next video.